This is a presentation of a project called Analyzing Flavonoids in Chocolate-Based Beverages. My name is Ernest Afoakwah, and I am mentored by Dr. Kim Spaccarotella. Several hours to days after strenuous or unaccustomed physical activities, our bodies may experience some pain or discomfort. This is referred to as delayed onset muscle soreness. These pains, in part, are caused by the buildup of free radicals in our muscles. Between the time that delayed onset muscle soreness leads to adaptation, antioxidants may reduce the severity of pain. Free radicals, like reactive oxygen species, are molecular entities that exist with an unpaired electron in their atomic orbital. This renders them unstable and very reactive. They are therefore able to interfere with the normal physiological functions of our bodies by attacking our healthy atoms. Antioxidants, on the other hand, are stable molecular species that are capable of neutralizing free radicals by donating an electron. The antioxidant that this study focuses on is catechin, which belongs to a group of phytonutrients called flavonoids. Specifically, as a flavonoid, catechin is able to neutralize reactive oxygen species in our bodies. We hypothesized that our chocolate milk samples should have some amount of flavonoids, particularly catechin, since it is a major flavonoid found in chocolate. The samples were treated with similar protocol adapted from Natsume et al. And Meng et al. Beakers were used to measure 50 milliliters of samples, and the same amount of heptane was added to the samples and let to stand for 24 hours. The samples formed gelatinous top layers that were presumed to be fat. They were removed. Next, the bottom layers were transferred into different centrifuge tubes and centrifuged at 4700 RPM and 19 degrees Celsius for 3 minutes. The centrifugation produced 3 layers: residual heptane in the top layer, fine chocolate milk in the middle, and particulate chocolate layer at the bottom. The fine chocolate milk in the middle layer was mixed with acetonitrile. This apparatus is an Hplc machine. The milk extract in acetonitrile was injected into the machine and ran for about 40 minutes. Another section of the protocol is a colorimetric assay adapted from Zestin et al. We used known concentrations of catechin to generate 2 standard curves, and the equations of the lines were used to calculate the flavonoid content of the samples. Based on this, we calculated the flavonoid content of low-fat chocolate milk to be 12.04 micrograms per milliliter, and that of low-fat and sweetened to be 14.06 micrograms per milliliter. Most of the samples on day 2 showed cloudiness, except muscle milk. We calculated the flavonoid content in muscle milk to be 10.6 microgram per milliliter. For the Hplc, we observed the chromatogram of our samples and compared them with data from Natsume et al. Most of our samples did not show strong peaks at the retention times of interest. Also, because we had focused on one flavonoid, we couldn't predict definitively what the other significant peaks in the chromatograms were. We cannot say with complete certainty that we extracted catechin in our samples, but we do believe that if we did, they were in minute amounts. In the future, we will refine our protocol, decrease the sample size, and possibly focus on other flavonoids. We will also perform Hplc at every step to better identify catechin.